This video provides a guided tour of the HinksPix Pro web interface. This video does not cover how to connect to the web interface. See our network configuration videos for that. The supported browser is typically Google Chrome and most other common browsers. Note that this is a non-secure HTTP connection. Your browser may indicate that you need to access this web interface in a non-secure manner. That will depend upon your particular browser. Once you've accessed the web interface, we have first the status menu. This status menu provides the date and time of the controller. This allows you to set a show to start and stop at a specific time if you're using SD card playback. It also has all the various different versions of the firmware. Each of the different CPUs on the board have different versions of firmware. This would be considered the normal major CPU right there. And over here we have Ethernet. The main ones to be concerned about here are received and transmit. And that number will increment, indicating that we are receiving data or transmitting data. This number for buffer available should normally be 0. And this is going to provide you the temperatures for the various different components. In this particular case, we have the CPU board at 88 and we have the SPI board at 73. The long range board does not show a temperature. This also shows the voltages of the long range expansion board. It's what it's currently seeing, and the SPI board. This can give you a clue as to whether or not maybe you're overloading the controller, or if you're using a dual power arrangement with 5 or 12 volts, for example, you can see that. Now, we also have Auto Live Update. When you choose this, you will see these numbers continuously update if you're using E131 ArtNet or other protocols. You can also reset those counters to 0. What they're comprised of is all the universes currently configured, and this is a default controller factory installed. There is nothing really configured other than the default universes. This is the universe number, this is the number of received packets, and this is the number of errors. For full information on this operational, see our test video. The next tab we have is the Design tab. The Design tab is a configuration generator. The first thing to understand is that you do require a SD card installed into the controller. Now, if you don't know if you have one, you can navigate over to the Debug tab, and this number right here, SD card active 1, should be turned on. So if it's a 0, you do not have an SD card. If this indicates any other number than 0, that indicates that you have a bad SD card or non-compatible SD card. It's important to note that you must have a 32 gigabyte or less SD card for operation of saving the data. Back to the Design tab. So if you have multiple designs, and you can see that we have multiple designs here, we can go ahead and select those and open them. And then that will load up the configuration. This allows you to have many different configurations for different types of shows. So you may, if you're doing concerts, have one for one particular show, or if you're doing a holiday lighting display, you might want to have one for Halloween and Christmas. It's important to understand that this interface is only used for configuration of non-X-Lights applications. If you're using the X-Lights application, you do not need to use this function. You use the visualizer. We are not going to cover the entire setup process of that. We do have an additional video that will show the exact process for configuring this, not only for long range, but also for SPI. So see our other videos for configuring output. Now, that configuration then is loaded, and we will just go ahead and navigate over here to Miscellaneous Settings, Manage Controller Configurations. Once you have created a configuration or design, you would go in here, select it, and install it. Now, once you install that configuration, it will then appear under these two tabs. So when we highlight these two tabs, what we get under port configuration first is what is really connected to your controller. Now, the HinksPix Pro is a modular controller, and it is supported as either 3 ports in this particular configuration. This is a version 2, so it has 3 ports, 1 through 16, 17 through 32, and 33 through 48. And we have 2 expansion boards. The first is a long-range expansion board underneath the CPU, and then we have an SPI board. So we can take a look at that now. Here we can see that we have the SPI board down here, and then underneath the CPU board is the long-range board, and those are connected via these ribbon cables. So the SPI board is this front ribbon cable, and the long range is this back one. So that allows us to know what's actually on the controller physically without connecting anything or looking at it. This is all automatic. Now, if you have a long range or a version 3 CPU, you may see additional ports that go all the way through 80. The last option is the DMX plug. So on the HinksPix Pro, there is a DMX output. So if we look over here, and this varies by version 2 or version 3, this DMX is a DMX 1990 plug. It is removable, and we have a ground, data plus, data minus, and that allows you output data to a regular legacy device using RS-45 DMX 1990, or technically E1.11. See our other videos for how to actually configure the RS-485. Now, when you go on one of these, you will be able to see the configuration. We do not support the configuration of a controller using this interface. It is possible to configure a controller. This will allow you to enter settings that are not functionally capable. So it is important to understand that you should configure this controller using either the Design tab, or if you're using X-Lite, using the Visualizer. It is useful to come into this setting and look at these to confirm that in fact you have a particular configuration set up correctly. And in here we can see that we have various SPI ports. These correspond in blocks of 4 because we have 4 jacks connected to this long range 1 through 16. If we look at the SPI ports, we can see again we have 16 SPIs, and we also have the ability to configure unusual options such as direction, RGB color order, null pixels, and gamma, such options. Again, no configuration should normally ever be performed under these tabs. The next is the E131 tab. That is linked over to the Support tab, and it uses an internal channel addressing system within the controller. That should not be confused with the DMX channels. Those are located here as the universe and the number of channels in that universe and their placement order. You can delete things manually or add things. Again, this is not supported. Now, you can also change the output speed. If you have a particular protocol that you're utilizing, you can change that output protocol to a different protocol speed. Normally 800 is typical for, let's say, 2811 type pixels or 2814, those types of pixels. If you have unusual behavior in your pixels, you may wish to check your specifications or choose a different speed. This will not damage any of your pixels. The next option here is we have the addressing mode. You can send unicast data, which is generally what we recommend, or if you're using a system, let's say a console that does multicast over a multicast address, you can use that also. We can also change the incoming protocol. So this is E131, also referred to as SACN. We also have ARTNet as a protocol and DDP. Now these options are all valid to change in this particular configuration without changing these. Now, you can go ahead and hit Save Changes on this page. Whenever you've made a change, you will need to reboot the controller for that. Now, moving to test outputs, we have the ability to test outputs. See our other videos for testing using this built-in interface. We can come into a particular output and choose specific ports to test and then output specific data. This is very useful for testing when you're using an application and you do not know if there is a problem with the application or the controller. See again our other videos. You can also test strings by a specific universe number here. All right. Now, the next option we have here is network. We'll go to wired Ethernet. This controller does have a wired connection. It does have a network switch in it, so either of the jacks will work as a network switch, and the controller will sit on that network. The default interface configuration is using DHCP when the controller boots up. If the controller cannot find a valid DHCP server on the network, it will default to 10.10.10.10 with a 255.255.255.0 subnet. Now, you can also see the MAC address if you're trying to give, let's say, a static IP address via DHCP, or you're trying to map those things. You can also change the host name, and that has the serial number of the controller plus Hinks. So this should be unique per unit. You can, of course, change the actual static IP address to anything, and then save that setting. Now, you can also set wireless. See our other videos on wireless. It is important to understand Wi-Fi cannot be used to access the configuration page. In other words, this interface you see here is not accessible over Wi-Fi. The intended function for Wi-Fi in this controller is for the purpose of controller-to-controller configuration and playback. If you're using it in standalone mode, a controller can link to another HinksPix Pro controller within Wi-Fi access range and keep the heartbeat between them. Again, I stress that you cannot access this web interface through the Wi-Fi interface. See our other video for complete configuration of Wi-Fi. The next option we have is miscellaneous settings. We're going to go to FM transmitter, and in no cases, unless you have a legacy device, we do not use the FM transmitter. This does not affect anything related to the FM transmitter. This is designed for an old or legacy output device. You should assume this does not apply to you. The next is operating mode. We have videos that explain what the different operating modes are, and you can set them here. If you wish to get your data from E131 or ArtNet, you would select Acquire Data over Ethernet. That means that the controller will respond to data it's receiving over Ethernet. If you are using the SD card playback function, you would need to tell it whether this controller is a master or a slave. You can also change these settings through the button interface. Again, if you make the change, you will need to save these changes and reboot. The next thing is the setting of the controller time. As mentioned previously, if this controller is in a standalone operation mode, not using E131 or other protocol to send data, you may need to set the time so that your show starts on a specific date and time schedule. This is typically used with X-Lights. You can also configure this option via the button interface while the controller is running and not have to access through the web interface. See that video for setting the time. We have blackout show. The inherent nature of DMX is that any particular output, once received, does not change. In other words, if you output and tell a pixel to turn blue, it will remain blue until it is told to change to another color. It is not uncommon for people to have sequence data being sent to the controller live, and when they're done, they wish for the lights to actually be off, which is not typical DMX configuration or spec. But you can force it to do that. So what you can do is you can say make all lighting black after sequence. And this will change how much time from the last command it receives in DMX before it says all pixels should go black. Alright, next thing here is bypass firmware checks. Normally this is defaulted. This controller can update from the internet, and generally you want to not update because you want to control the updates you perform. You can turn this on or off here. Alright, you'll see some additional information. It talks about the debug tab and its current status of the firmware. See our other videos for how to see the status of the firmware, not only through the web interface, but also through the button interface. Now, we can also control a fan from the HinksPix Pro. There is a header. See our other videos for where that is located on the unit, and that will allow you to control a fan based on the temp of the CPU. Now, as mentioned previously, on the status tab, we actually have two temps. The temp of the CPU will generally be running higher than that of any expansion board. So please take that into consideration. In this particular case, our CPU is running at 88 degrees Fahrenheit and the SPI board is running at 73. So, if you do wish to have fan control, you do need to provide power to the CPU board through the header and then plug in a fan. Generally speaking, we do not recommend using fans, as those often will draw in additional heat, snow, water, bugs, all manner of things. It is not normally a safety issue. Temperatures that humans feel are high, such as 130 degrees, are not a problem for this controller. So, next on our list here is manage controller configuration, and we showed you this previously. This is what allows you to go in here and select your configuration that you've previously done with the design tool. Again, see our other videos. Install that selected configuration into the controller. It'll say it's installed, and then reset the controller. Once you go to the reset, you will need to hit the reset button and the controller will reboot. You can also reboot the controller from the controller itself using the reset button. This is the debug tab. On the debug tab, there are a lot of internal helpful things that if you are involved with a very complex, unusual issue, you can get additional data. The main issue would be this right here, SD card active. I think we've mentioned this already. If there is a 1 here, that means your SD card is installed. You should never see anything other than a 0 for SD card errors because it needs only 32 gigabytes or less for the SD card. That concludes the web interface overview.